Okay, welcome to the first of many recordings by me, Mr. Maycall, for a home lecture in our chemistry class. We'll be doing these about 3 days a week and a live session about 2 days a week until, well, whenever we get back together until the end of the term, whichever one comes first. Today we're going to go over topic 9 exam that you guys took right before all of this has happened. You guys went home. I'm here on the home page or the modules page. It's the same thing in our chemistry lesson on topic unit 9, topic 9. Oh, I should probably change that to topic 9 because that's what it is. Topic 9. And I'm down here at the topic 7 through 9 exam. So I'm going to go over this, run through this thing real quick. Hopefully this will answer any questions you guys have about your own. Hopefully you guys can have two windows open so you can follow along in this video and look at your own exam. Remember, there's a lot of shuffling going on in these exams. So what I am doing is not necessarily what you will see, but hopefully give a good idea on how you can get a better score. So, just let you know, I have opened this up, so you can just take this whenever. I give everybody 2 attempts. It's going to be a 60-minute timed exam, however, so you only have 60 minutes to do it. Remember that it is open note, not open friend, not open internet. You're welcome to use any of our notes on this exam from our workbook. So, I'll go ahead and run through this bad boy with you guys. You guys can correct yourself as I do this. So it says here, name the following binary compounds. This is going back to topic 6 and 7, just naming things, non-metals. So they are going to be the non-metal naming scheme. They're covalently bonded. So dicarbon trioxide is right there. Same here. Which is the correct formula for octaphosphorus dichloride? So octaphosphorus, P is phosphorus, octa is 8, and then dichloride, Cl and 2, so chloride, and there's 2 chlorides. Remember, these numbers are supposed to be subscripts, like it says right there. So octaphosphorus dichloride. Need to know how to name all these things. We are on number 3. Balance the following equations. Potassium chlorate yields potassium chloride plus oxygen. So we got to remember what chlorate is. And chlorate, grab out my notes because I honestly can't remember if it's 2 minus or 1 minus. I can't remember. But on the back of my book, I got a handy dandy chart. Tells me by polyatomic ions. So let's use it. Cl. Potassium is K. Chlorate is going to be a chloride, a chlorine with 3 oxygens, and it's 1 minus, right? So this is a minus, that's a plus. It's all balanced. It's good to go, and that's going to yield some number of potassium chlorides. So potassium ides, remember, is just the element, so chlorine. So K, again, is a plus, and Cl is a minus, so that balances out. Plus some number of oxygens. And remember, oxygen is a diatomic gas, which means there's going to be 2 of them. So we have 1 potassium. We can make our little chart right here. Why not? Here are my reactants. Here are my products. So here I have 1 chlorine, 1 potassium, 1 chlorine, and 3 oxygens. And then on the other side, I have potassium, chlorine, and 2 oxygen. So that's going to be our problems right there, the 2 and the 3. And of course, the common denominator on that's going to be 6. So that means I will have 2 of these. will have 3 of those to make everything 6 here and 6 here. And of course, that means I have to double everything right there to make 2, 2, 2, and 2. Okay. Number 4, balance the following equations. Oh, good. Here we go again. Potassium phosphate. So let's write this down. Potassium's K. Phosphate is going to be PO4. No, sorry, PO4 3 minus. PO4. And that's a 3 minus. And this is a single plus. So if we do the crisscross method of naming these things, that's going to be K is going to be 3, and the PO4 is just going to be 1. So K3 PO4, and that's going to yield, plus calcium nitrate. Calcium nitrate is going to be NO2, I believe. Nope, nitrate's NO3 minus. And calcium is going to be a 2 plus. Looked it on my periodic table just to make sure, and it is. It's a 2 plus right there. So I do the crisscross method again, and that means I'm going to have 2 NO3s and 1 Ca. Remember, you don't have to have the charges written in, but I do that when I'm naming them just so I make sure I have those subscripts correct. And that's going to yield potassium nitrate. So this is a double replacement reaction. So K and NO3. And that's a single minus, that's a single plus, so that's good. Plus calcium phosphate, so Ca and phosphates PO4. That's a 3 minus, and this is a 2 plus. So we'll do the crisscross method here, and there's going to be 3 of those. And 2 of these. So I'll make myself a little table here. Here's my reactants, here are my products. I have Ks, there's going to be 3 Ks on this side. It looks like there's just 1 K on the other side. I have a PO4 and a PO4. Whoops, didn't leave a lot of room on that to write. That's all right. So this one I have 1 PO4 on this side, and I'm going to have 2 PO4s on the other side at the moment. Of course, that's probably, well, obviously that'll change. Something will change as I add my coefficients. Then I have CAs. And it looks like right now there's 3 CAs on my product side and only 1 on my reactant side, and NO3s. In NO3s, there's only 1 NO3 here, and it looks like there is going to be 2 NO3s on the other side. Okay. So now I have to start balancing them out. Looks like obviously here 3 Ks and 1 K, so I could add 3 of these right here to start. See what happens. That'll add another 3 NO3s there. Uh-oh, right away I see a problem. We have 2 of these and 3 of these. That means I'm going to have a least common denominator going on right there, right? So I better bump this thing up to 6. Of these, and that's a 2, so I'll do a 3 of those. Hope this is legible to you guys. So 3 and 6. Because I see I have a 3 here and a 2 there. That means my least common denominator between the 6 is going to be a 6, right? I bet you everything else will probably work out pretty quick now. So I'll have 6 NO3s here. I'll have 3 CAs. Isn't that convenient? Because I have 3 CAs on the other side. I have 6 Ks right here. So that means I better double everything right here. So I get 6 Ks here. It's supposed to be a 6. Use your imagination. That's a 6. That's a 6. So now I have 2 PO4s here. 2 PO4s there, 3366. Yay, everything worked out. So that's a 2, a 3, a 6, and that's just still a 1. So the question is, what's the coefficient for potassium phosphate? Here's potassium phosphate, and it looks like it is 2. 2 potassium phosphates. I'm going to write that down again, just in case I see this one again later in the quiz. I don't know if I am or not. Again, I put so many darn things on this, I don't remember what I'm going to see and what I'm not going to see. Two NH3s, that, my friends, is a synthesis reaction. Classify this reaction. Oh, right there, look at that. There's carbon, there's a bunch of oxygens making carbon dioxide and water. You better believe that's a combustion. Question number 7. A mole is how many particles? I know that. 6.022. And it wants me to round it to the nearest thousandth, which it is. What's a mole? A mole is a huge number. Yes. It's 6.022 times 10 to the 23rd. Yes. It's Avogadro's number. Yes. It's a way to keep the get from the atomic scale to grams. Yes. So all of those things are correct. Number 9. How many grams per mole of sodium nitrate? So we'll grab out our periodic table. So really quickly, let's write down sodium nitrate. Sodium Na, nitrate, it's going to be an NO3 minus. And sodium's a single plus. And nitrate's a single minus. I'll write that in for the fun of it. You don't have to. Actually, you're not supposed to, but I'll just show that those balances out. Those charges balance out. So it's balanced, and now we just need to start counting up how many of these things are. So you know what I like to do. I like to write down the number above it. So sodium's 22.99. Nitrogen is 14. I know that. 0.01. If I'm rounding to the nearest hundredth, which is exactly what I'm doing. And oxygen, I know that one too. That's 15.99. I can grab out my handy dandy calculator. And it looks like I have 3 oxygen, so I'll start with that. 15.99 times 3 plus 14.01 plus 22.99. That gives me 84.97. Hey. And it tells me to round to the nearest tenth, which I did. Here's another fun grams per mole question. Lead bromide, lead 2 bromide. Remember, that tells me my charge of lead. I'll write it down right here. So Pb plus 2, because it's lead 2. And then bromide. Bromide, I don't remember what bromide is. Oh, duh, it's ide. So it's just bromine. Sorry, I was looking for a polyatomic ion, but it's ide, so it's just bromine. And bromine is, again, it looks like bromine is a halogen, so that's a single minus. So Br minus, so crisscross method, I'll have 2 bromides and 1 Pb. So when you write this down, it should just look like Pb Br2. That's what it should look like. But just matching up my charges, that's a 2 plus, that's a minus, so I better have 2 of those, right? 2 minuses to balance out my 2 pluses. Okay, so lead, I believe that's 207.2. It is. Looking on my periodic table. And bromine, I can't remember what that is off the top of my head. It's 79.90, but I'll just put 79.9. There's 2 of those and 1 of these. Grab out my calculator again. So I have 2 times my 79.9. Whoops. And then I'll add that. See, there's two 79.9s, and I'll add that to my one 207.2. And that's going to be 367 on the nose, it looks like. And I have a small error for room for error. If you're 366.9 or something, you should still get full credit for that. But I came into lead. Number 12, lead 2 nitrate reacts with sodium bromide to produce lead 2 bromide and sodium nitrate. When you balance this reaction, what is the coefficient of sodium nitrate? That's another balancing question. So, lead 2 nitrate reacts with sodium bromide to produce lead 2 bromide and sodium nitrate. So, lead 2, I'll write it up here. Oops. Lead's Pb, and that's a 2 plus. And nitrate is NO3 minus. And when I crisscross this, I will end up with 2 of these guys plus sodium bromide. So sodium's Na. Bromide is Br. And that's a single plus and that's a single minus, so it's good just the way it is. And that's going to yield lead 2 bromide. Hey, we just did that. PbBr2 plus sodium nitrate, Na, which is a single plus, and nitrate's a single minus, so that is good. All right, now we just got to balance this. Here's my reactant side. Here's my product side. I've got lead on one side, nitrate. That's an NO3. Na and Brs. And I should have everything on the other side as well. Otherwise, we are violating the law of conservation of mass. Na and Br. I count them all up. Looks like I have one lead on this side, one lead on that side. Looks like I have 2 nitrates on this side, and oops, that's not right. NaNO3. NO3 is a single minus. Sorry, guys. It's just NaNO3. There's no 2 there. So there's just one NO3. Na is a minus, so there's one of those and one of these. And bromine, I have 1 bromine. On this side, I have 2 bromines. So pretty straightforward. Let's go ahead and focus on the NO3s first for no apparent reason. I'll double this NO3 by adding the coefficient of 2 right there. That'll double my NO3s, and it's also going to double my sodiums. But isn't that convenient because I just need to double my sodium and bromide right there to get 2 sodiums and 2 bromides, and everything's balanced out. And again, I'm going to jot this down because I'm pretty sure this is coming up here in just a minute again. So NO3, 2 plus 2 NaBr yields PbBr2 plus 2 NaNO3. So when I balance this reaction, it's the coefficient for sodium nitrate. There's sodium nitrate right there. It looks like I have 2 sodium nitrates. Yay, 13. We're getting there, guys. Oh, look at that. It's the same reaction. So lead 2 nitrate reacts with sodium bromide to produce lead 2 bromide sodium nitrate. Same reaction. When you balance this, what's the coefficient of lead 2 bromide? Well, going back to what I just wrote down, the lead coefficient for lead 2 bromide is just 1. Lead 2 bromide, there's just 1 lead 2 bromide. It's pretty simple. I hope you guys realize this is just like the practice problem assignment that I give you guys. And of course, the products and reactants are different, but it's the same idea here. Okay, lead 2 nitrate reacts with sodium bromide to produce lead 2 bromide and sodium nitrate. So lead 2 nitrate reacts with same reaction. How many grams of lead 2 nitrate would you need to produce 195 grams of sodium nitrate? So we're going to start with what we have. In this question, I have 195 grams of sodium nitrate. So I'll start off with that. 195 grams of sodium nitrate. So I'm trying to write pretty small here. Sodium nitrate. And I am in grams, and I need to go to moles, so I'm going to write down my grams, however many grams of sodium nitrate this is. So I can figure this out in my calculator. Oxygen, I know oxygen's 15.99. Sodium or nitrogen, I know that's 14.01. Looking this up on my periodic table. Sodium's around 22.9, I think. Hold on, let's look it up. It is 22.99. So sodium, Na, that's an A, believe it or not, is 22.99. All right, plug this into our calculator. I'll start with my 3 oxygens. So 3 oxygens is going to be 15.99. Whoops. 15.99 times that by 3. Then I will add my 14.01 for my nitrogen and my 22.99 for my sodium. And I'm actually going to write this on my scratch piece of paper real quick. Right above it, sodium nitrate is 84.97 grams per mole. So 84.97. So 84.97 grams per mole. So that's per 1 mole of my sodium nitrate. And yes, you should be writing down sodium nitrate here. Always write down your... Always write down your units, you guys. And I'm going from moles of sodium nitrate. I want to know how many grams of lead 2 nitrate I would need. So I'll write down my mole. Oh, double check my coefficients. Where my coefficient goes is where I look at my balanced reaction. So I'm going to go from moles of sodium nitrate. Oops, NaNO3. And I'm turning it into lead, down here, lead 2 nitrate. So Pb nitrate, NO3. And I believe I had 2 of those because this is a 2 plus and that's a single minus. And then I look at my balanced reaction. I wrote that down just a moment ago. And it looks like I have sodium nitrate, 2 moles of sodium nitrate for every 1 mole of PbNO3. So this is 1 mole, and this is 2 moles. Where did I find that? I found that from my balanced reaction. I wrote my balanced reaction down right here on question 13. So I looked up my balanced reaction and saw that, oh yeah, for every 2 moles of sodium nitrate, I get 1 mole of PbNO3. Now I'm in my unit that I want in moles. I got to convert that to grams. So here we go. I'll write down my moles of PbNO3 NO3. Oops, that should be lowercase b. Sorry, guys. PbNO3. There's 2 of those. Now we got to figure that out. Did I write that down earlier? Nope, I have not written that down yet, so I'll do it right now. Lead is 207.2, I remember from just a moment ago. Nitrogen, I know that one. That's 14.01. And oxygen, that's 15.99. I know all those numbers from my periodic table. So now I can add all these things up and figure out how many grams per mole this is. Now remember, PbNO3, there's 2 of those NO3, so I'll start with the most complicated part first and work my way out when I do this calculation. So I have 3 oxygens, so I'll do 3 times 15.99 plus 1 nitrogen. This is 14.01. I'm going to multiply all of that by 2, which is 75.99. Then I'll add in my last 207.2 here for my lead. There's only one of those, and I get 283.19. I'm going to write that down right now on my scratch piece of paper for easy access later. 283.19, which would be my answer. Nope, sorry, that's not my answer. That's what goes right here. Then we could do our answer. So I get 283.19 grams of my PbNO3. Of course, there are 2 of those. Use your imagination. All right, PbNO3s. So now I'm in grams of PbNO3s, which is what they are looking for. They want to know how many grams of sodium or of lead 2 nitrate, which is PbNO3. Okay, so now I can plug and chug this into my big old equation right here. I like to do, one way to do this. There's lots of different ways to do this. You can multiply everything on the top, write it down, divide it by everything on the bottom, multiply together. Another way you can do it is think about these things as all these fractions are multiplied together, which, I don't know, is kind of easier for me to do all at the same time. So 195, I'm going to multiply that by, in parentheses, 1 divided by 84.98. I'll just go ahead and get equals there. And then I will multiply that by, in parentheses again, well, I could just, this is 1 over 2, that's 0.5. And then multiply all that by 283.19. And we get 324.91 grams, which I think it wants us to do. Oh, it's correct significant figures. So it looks like we only have 3 significant figures here. So our correct significant figures would just be 324.9. That better be 325. Oops, no, not point. Sorry, 325. There we go. So that's in the correct significant figures. All right. I hope you guys are following along. Hold on to your questions. Either email me or talk to me tomorrow if you have questions about this. I'll have a live lesson tomorrow. Okay, moving on. Question 17. We're almost there, guys. Yay! The formula for percent yield. Yep, okay. Is that right? Did I skip one? Oh, I totally skipped. Okay, I skipped a couple. Okay, 15. Lead 2 nitrate reacts with sodium bromide to produce lead 2 bromide and sodium nitrate. If you started with 100 grams of both reactants, PbNO3 and NaBr, what are the limiting reactions? So I hope you guys are realizing this is the same equation as before. All we got to do now is we got to do 2 quick stoichiometry problems with lead nitrate and sodium bromide with 100 grams of each to see which one comes up with less of my product. Honestly, guys, if I was doing this on my scratch piece of paper, this would be a lot easier because, well, I just had that stoichiometry problem up. I could have used the same numbers, but that's okay because it doesn't matter which product you choose to do this with, right? You can choose either product. Just choose the same one for both. So let's just start with PbNO3. PbNO3. And it's actually PbNO3 2. I guess that's a typo. I'll go back and fix that. PbNO3 2. Right? Am I right? I better be doing that right. Yeah, nitrate's a minus. Okay. And lead's 2 plus. Just checking. Okay. So PbNO3 2. And that's going to be another big old stoichiometry problem here. And we're going to have 100 grams of each, right? So 100 grams of this. And I'm actually going to write this down so I have a convenient table for myself for later. So 100 grams of PbNO3 2. I'll do a little smiley face here to remind myself I never ever. That's the most frightening smiley face ever. All right. To remind myself I don't do things right here, right? That's not. I don't know what that is. That's some weird dude. Hi, guys. All right. Moving on. So 100 grams of PbNO3. I'll write down grams of PbNO3 down here. I'll just write this all out right now with all my units first. So I go from grams of PbNO3 to moles for every 1 mole of PbNO3. And we'll figure that number out in just 1 second. We'll plug that in. Do I have it already? Oh, I do. It's 283.19. Lovely. So we just did that one, the last problem, 283.19. Sorry, it's pretty terrible writing. Hope you guys are following along. So it's 283.19 grams of lead NO3 for every mole of lead NO3, and it's NO32. Just be writing that down. Now I'm in moles. Remember, I go kitty corner, so I'll write in my moles of PbNO3. And you choose any reactant you want. I'm just going to go PbBr2 because it's a simpler thing to calculate here. Of course, I already have the one for NaNO3, but whatever. So I'll do it moles of PbBr2. And on my balanced reaction, which I have written down conveniently on my scratched piece of paper, it looks like for every 1 mole of PbNO3, I get 1 mole of PbBr2, so that just cancels itself out, right? 1 over 1's 1. And then I have my moles of PbBr2. And I got to figure out how many grams of PbBr2 it is. So that's the last thing we got to figure out before I do our final calculation. So lead, I remember that's 207.2. Bromine's around 79, I think. I can't remember. Look it up again. 79.9. So that's 79.9. And then I can grab up my calculator to figure that out. BR2, so I do 279.9s times 2 plus 207.2. Now it looks like, oh yeah, 367. We did that one already. Oh, it's right there. Look at that. I have it in my notes already. I'll say that looked familiar. Okay. 367. So now I can plug all this into my calculator. Start with 100 grams of this. Multiply that by 1. So 100, multiply that by 1 divided by 283.19. Skip that because that's 1 over 1 is 1. And then multiply all that by 367. And we get 129 grams. So this one is 129 grams. Of my PBBR2. I'm going to go ahead and write that down on my scratched piece of paper. All right. Excuse me. All right. So now we need to do the same thing with our. So I'll start off with my 100 grams of my NABR. And I'll go from grams of NABR to moles of NABR. And I'll just write in all my units before I worry about my numbers. So we're going to be in moles of NABR. And then just make sure you're choosing the same product. Doesn't matter which product, but we chose last time, or I chose last time, moles of whatever it was, PBEBR2. Why do I keep doing a capital B right there? PBBR2. I'll look this part up in my balanced reaction just a moment. I'm just going to keep writing my units down. Moles for every 1 mole of PBBR2. I get, and I just wrote this down, 367 grams. We did that in our last one. We did it in a problem up above too, if you remember. So grams of PBBR2. I'll fill out the rest of these numbers. I'll look at my balanced reaction. It looks like I have 2 moles of NABR for every 1 mole of my PBBR2. That was from my balanced reaction from the question above. And then NABR, do I have that written down yet? Nope, I do not. Okay, so we'll calculate that too. So sodium, I remember that. That's 14.01. Bromine, that was 79.9. Oops, 79.9. And there's 2 of these, right? Nope, just 1. So there's a 1 minus and a 1 plus. That's pretty easy. So 14.01 plus 79.9 equals 93.91. I'm going to write that down too. Hey, look at that. I have all of my grams per mole for all of these now. 0.91. And I'll write that in right here. Okay, just need to plug and chug this through my calculator again and figure out how many grams I can make with 100 grams of sodium bromide. So we'll have 100 again, multiply that. Put this in parentheses, 1 divided by 93.91. Hit the end parentheses. I'll multiply that by 0.5, which is a half. Right there, 1 over 2. Multiply all that by 367 to get a grand total of 195 grams which, if you guys remember, my previous one, I only made 129 grams. So this is definitely more, so this I'll have excess of, which means my other one, my lead nitrate, is going to be the limiting reagent. So it was 195 grams going from NaBr. The other one was 100 grams of lead nitrate. And I only made 129 grams of my PBBR2. So this one is my limiting reagent because I made less grams. This I made more grams. I'll have excess of my sodium bromide left over at the end, which is good. Maybe we should write that down because knowing what's coming up, having read through all the questions before I took the test, I know it's going to be asking me what the limiting reagent is. So we knew it was the lead nitrate rather, was my limiting reagent. Which is this next question. Consider the above reaction with sodium bromide to produce lead 2 bromide and sodium sulfate nitrate. If you started with 138.2 grams of both my reactants, how much excess reactant would I have left over? So this is a little bit different number. It's not 100 grams, it's 138.2 grams. So I need to rework this real quick. This is the same exact equation I just had, but I will stick back in 138.2. I know that's going to be my excess reagent, would be my sodium bromide, so that's all I got to do. So I'm going to rewrite this in as 138. I'll do this one up here. 138.2 grams of my excess. My excess, guys, if you remember, is going to be my sodium bromide, NaBr. And I'll plug all this right back into the conversion table I just had. Which is going to be 1 mole of sodium bromide, NaBr, for every gram, which is 93.91. Grams of sodium bromide. And then looking at my conversion table, I know it's 2 moles of sodium bromide, right? So here's moles of sodium bromide. So I'll write in moles sodium bromide. And I know it's 2 moles for every 1 mole of, and again, it doesn't matter what you choose. I'll stick with my last reaction, which is lead bromide. If you chose the other product, it really doesn't matter. Just keep it consistent, whichever one you choose. I chose randomly PBBR2. Just seemed like an easier thing to deal with. For every mole of PBBR2, we just wrote this down, so I have 367 grams. I can plug this into my calculator. To be 138.2 times, in parentheses, 1 divided by 93.91. Again, times that by a half, so I'm going to just multiply that by 0.5, and then multiply all that by 367. I'm going to end up with 270 grams. Last time we ended up with about 195, so that makes a lot of sense to me. So now I'm going to start this whole thing backwards, starting with, instead of 367 grams of this stuff, right, which is what I got off my periodic table, I'm going to be starting with what I have. I have made 270 grams. Oh, and I got to subtract. Oh, I have to do it twice. Gosh darn it. Okay, we have to do it twice. So I am going to have 270 grams of this. .04. So sorry, we have to subtract this from the other one to figure out how many excess grams we have. I guess we could have done it the other way too. It doesn't really matter. That's okay. There's multiple ways of doing this problem. So I'm going to figure out how many grams of PBBR2 I make with my 138.2 grams of my other reactant. So I'll do that right here. So same thing. I'll start with 138 grams. Well, 0.2 grams, but instead of the NABR, I'll do the other thing, which is PbNO3. And following my units, I'm going to have grams of, let's see, I have this written down, 283.19. .19 grams of PbNO3. For every 1 mole of PbNO3. So on my balance reaction, I saw that it's going to be a 1-to-1 ratio. Yep, it's a 1-to-1 ratio. So I'm just going to I can even skip that step really. I'll write it in for the fun of it. So it's 1 mole of my PbNO3 NO3 2, and I'm going to go to my PBBR2, PBBR2, and now I'm in moles of PBBR2. And we got to figure out how many grams that's going to be. Which we have conveniently written down right there as well, 367. So I can plug and check this into my calculator as well. Find a spot I can actually see my calculator as I type this out. That'll work. So I'll start off with my 138.2. Multiply that by 1 divided by my 283.19. In parentheses, skip this step as it's 1/1 and multiply that by 367. It'll be 179. So I need to take this number and subtract 179. I'll do that down here. So I ended up with 179 grams of this stuff minus 270, sorry, 0.1 minus 270.04. And that's going to be how many grams I could have made, but I didn't from my excess. And then I can figure out my excess. So that'll be 179.1 minus, oops, other way around, guys. I know how to subtract and add. It's 270 minus 179. Sorry about that. I'm just going to do it this way and remember that I'm going to get a negative number, but I just want the absolute value of it. So 270.04, and I'll get 90.94. Okay, so now we can do our last stoichiometry equation on this one, which is taking this many grams, which is the excess that I have, and then figure out how much product I would have made, and figure out how much of my excess reactant I have left over. So 90.94 of my product, PBBR2, PBBR2, start over. Oh my God, my children are asking, hold on, I have to yell at my kids. Okay, sorry. So I have 90.94 grams of my product that I would have made, but I didn't because I ran out of my other reactant. So that's PBBR2. And I will write down how many grams that is, which is 367 grams per mole. PBBR2. For every 1 mole of PBBR2. Write down my unit down here. So I need to know how many moles of PBBR2 I get for however many moles of my excess, which was the NABR. So when I look at my balanced equation, it looks like I have 2 moles of NABR for every 1 mole of PBBR2. So that's a 2-to-1 ratio. And then I can write down my moles of NABR to grams of NABR, and I wrote that down, which is 93.91. Okay, now we can just plug and chug this into our calculator and finally get our excess. 90.94. I'll multiply that by 1 over 367. In parentheses, times all that by 2, and then times all that by 93.91. Yields 46.54. 46.54. Make sure my units are right. And it says to round to the nearest hundredth. which it looks like is good. So that should be the excess amount of my reactant. In this case, it would be my NABR is my excess. I ran out of this first. I have excess of that, and we figured out how many grams of my NABR I have left over. I know it's a 3-step stoichiometry problem. I know it's a total pain in the butt. Welcome to chemistry, my friends. All right, no, you've been here for a while. Okay, moving on. These get easier now. 17, the formula of percent yield is my actual divided by theoretical times 100. Then it says consider the above reaction. If I have 4.8 times 10 to the 23 molecules of lead bromide, how many grams of lead bromide would I have? All right, we can do that. If I have, remember you always start with what you have. So I have 4.8 times 10 to the 23rd particles. I'll just say part of lead 2 bromide, lead PbBr2, right? Bromide's 2? Yes, it is. Lead bromide. Okay. I'll put this in my happy little stoichiometry problem, my conversion table here, and say, all right, so I'm in particles of lead bromide, and I know that if I had 6.022 times 10 to the 23rd particles of lead bromide, I know I would have 1 mole of lead bromide. And if I have 1 mole of lead bromide, I know that I would have, let's see, we wrote this down earlier, lead bromide is 367 grams of lead bromide. Plug that into our calculator one more time. See, I know I can get rid of this times 10 to the 23rd because it's also right there. That makes my life a little bit easier. Remember, I can cross out anything that's on the top and bottom of any part of this. So I can cross all this stuff out. And then I just have 4.8. Divide that. Be careful, guys. That only works if you have exactly 10 to the 23rd on both of these, which I did. If it's anything besides that, you got to cancel out only what you can, not everything. In this case, it's the same, so I can cancel it out top and bottom. So 4.8, divide that by 6.022, and I'll multiply all that by 367. And I'll end up with 292.53 grams. It says nearest whole number, so I'll just do 293. 293. 292.5. So yeah, 293 grams. Okay, 19. Near the end here, folks. I know this is long, but we're almost there. Consider the above reaction. If your theoretical yield sodium nitrate was 171 grams, but you made 107 grams, what's your percent yield? Well, that's pretty easy. I can just stick that in here. I have theoretical yield's 171, so I'll put that on the bottom. So 107, divide that by 171, and I get 0.6257. You multiply that by 100%, and you get 62.57. It says here, round to the nearest whole number, which would be 63%, is my yield. And the last one is, from the previous question, consider what your theoretical yield was. Assume you have isolated your product to a pure sodium nitrate. Which of the following actual yield of sodium nitrate is not possible? So I could not have 700 grams if it's a pure substance because, um, well, my maximum yield could only be 170 grams, right here. So I could only have a maximum of 171 grams. If I go over that, then we're making matter out of nothing, and that can't work. Thanks for watching this video, guys. Sorry I went a little long. You guys have a week to retry that topic 7 through 9 quiz. You don't have to, but I would certainly suggest it. If for some reason you haven't taken that quiz yet, make sure that you do. You want to have at least one grade on that, guys. It's going to be part of your exam grades. So next time, tomorrow, we will be doing a live conference. So tomorrow, when you log in for chemistry class, please hit the conference button. There'll be something called a big blue button. It should be pretty straightforward. You'll join the class by clicking on the big blue button, and then it'll be a live streaming class where we can go over things, answer questions, and start topic 11 tomorrow. You feel free to email me. Otherwise, I will see you, all of your wonderful faces tomorrow. I hope you guys are surviving this long, long video. Please study it. I hope that you find it to be helpful. I will see you tomorrow.